The standard model of physics needs 26 free parameters. General relativity adds more. Dark matter, dark energy, the cosmological constant, all fitted, never derived. What if every single one of those numbers followed from just two? Today we present the complete six-dimensional geometric field theory. 2 axioms, 57 observables, 0 free parameters. Everything begins with the 24 cell, a regular polytope in 4 dimensions. It has 24 vertices, 96 edges, 96 triangular faces, and 24 octahedral cells. It is the only regular polytope in dimension 4 or higher that is simultaneously self-dual and has a crystallographic symmetry group. That symmetry group, the Weil group of D4, has order 1152. No other polytope carries this unique combination of properties. This is not a choice. It is the unique geometric starting point. From the 24 cell, we extract exactly 2 numbers. Delta equals 1 over 24, the minimal angular deflection of one vertex among 24, the lattice tension. Capital delta equals 5 over 24, the conflict fraction, the largest independent set of the 24-cell graph. These are not chosen, they are computed from combinatorial graph theory. From these 2 fractions, everything follows. Add them, 6 over 24 equals 1/4. Divide, delta over delta equals 5. Take the golden ratio, delta over delta is the Fibonacci limit. The ratio delta over delta equals 5, and the Fibonacci condition yields the golden ratio phi equals 1 plus root 5 over 2. The 6-dimensional embedding produces 6 cones, each with a half-opening angle of exactly 30 degrees. This angle is not assumed. It equals arcsine of 1 over 5, the lattice geometry. 6 cones in 6 dimensions tile the angular space and seed 3 fermion generations, the gauge group structure, and the cosmic energy partition. The 6 cones stack into an effective spectral dimension. D star equals 67 over 24, approximately 2.792, not 3, not 4, a fraction. At the Planck scale, D star runs to 2, matching lattice quantum gravity simulations. This dimensional flow from 2 to 67 over 24 drives inflation, sets the gravitational action, and encodes every coupling constant. The fractional dimension gives a modified gravity action. F of r equals r to the power 67 over 48. At galactic scales, the running Newton constant flattens rotation curves. No dark matter particles needed. The Tully-Fisher slope is 91 over 24, approximately 3.79. The observed value from the Spark survey, 3.85 plus or minus 0.09, that is 0.65 sigma. A transition radius of 1.82 kiloparsecs marks where the modified regime activates. Dark matter is geometry, not a particle. The lattice encodes the gauge couplings. The fine structure constant inverse, 2 pi times d star cubed plus delta times d star equals 136.82. The measured value is 137.036, 0.16% deviation. The strong coupling at the z-mass, root 2 over 12 equals 0.1179, within 0.05 sigma of the measured value. The weak mixing angle, sine squared theta w equals 1/9 at the Planck scale plus the electroweak running correction 0.12011. Result 0.23122. The experiment 0.23122 plus or minus 0.0003, a perfect match. 3 generations arise because phi to the n must be less than 5. Phi squared, phi cubed, all less than 5. Phi to the 4th is 6.85, too large. Exactly 3 generations. The Higgs mass, 124.95 GeV, observed 125.25 plus or minus 0.17, 1.8 sigma. The 24-cell lattice has 2,304 combinatorial microstates. Count them: 115 baryonic, 600 cold dark matter, 1,589 dark energy. The sum, 2,304. Exactly. Cosmic flatness is a combinatorial identity, not fine-tuning. The baryon to photon ratio, delta to the sixth times 1 minus delta over 8, approximately 6.27 times 10 to the minus 10. Observed, 6.14 plus or minus 0.19 times 10 to the minus 10, 0.67 sigma. The dark energy equation of state, W equals minus 67 over 72, approximately minus 0.931. This is the one prediction intention, 3.3 sigma from minus 1.03, the sharpest falsifiable claim. Inflation in SDGFT is not driven by a scalar field. It is the dimensional flow itself, d star running from 2 at the Planck scale to 67 over 24 at large scales. This yields about 60 e-folds of expansion. The spectral index, 0.967, within half a sigma of the Planck measurement. The tensor to scalar ratio, 0.013, detectable by CMBS4 and Lightbird. No inflaton, geometry inflates. The full ledger, 57 observables, 12 exact, 23 within 1 sigma, 2 good, 2 fair, 1 tension, 9 compatible with current bounds, 5 awaiting future data. The weighted mean deviation, 0.63 sigma. For comparison, a random theory matching 25 observables at this level has probability 3 times 10 to the minus 8. 5 experiments will decide the fate of SDGFT within this decade. Euclid and DESI will measure W0, predicted at minus 0.931. CMBS4 will measure R, predicted at 0.013. The Cherenkov telescope array tests Lorentz violation. Lunar laser ranging constrains G dot over G, and JWST will refine sigma 8 and S8. If W converges to minus 1, SDGFT is falsified. If W equals minus 0.93 and R equals 0.013, geometry wins. 2 axioms, 0 free parameters, geometry decides.